Welcome to the Faculty of Industrial Design Engineering. This is where the magic happens. Follow me.
What is the project?
Innersport Lab Den Haag was founded in Scheveningen last year and started 7 projects about sailing. They want all hands on deck to set sail for an Olympic medal at the 2016 Olympics in Rio. The TU Delft and Stantec got on board with the lab to collaborate in one of these projects to design a sail simulator. Our part of the project is done for a course in an Industrial Design Master. The Project Advanced Product, or PAP for short, is the second to last course before graduation. The goal of the course is to design an advanced product, in this case a sail simulator. Our contribution is only the first phase of the sail simulator project. Future groups will continue the next 4 years by improving on solutions created by groups that were before them. Basically, we are all in the same boat together, and we can only reach land by documenting our progress well and keeping it understandable.
Why industrial designers? What do they bring to the table?
The choice for industrial designers to build a sailing simulator might not be the obvious one at first. Mechanical or electrical engineers would seem a more logical choice. These students are very good in their field, but a simulator needs more than just a solid mechanical base or good programming and wiring. This is where the industrial designers come in. We can combine some skills of both electrical and mechanical engineering and as well bring our knowledge of human factors and our overall user-centered approach to the table.
Why a simulator?
In sailing, nothing goes beyond getting into a real boat and sailing on real water. However, weather conditions are an ever-changing thing, making it difficult to actually see if the sailor's skills have improved or the wind was just blowing a bit harder or the current favored him this time around. A good simulator can be very close to sailing in a real boat with the advantage that the wind and water can be exactly the same every time going around the course. So a few seconds faster means there is improvement, and not the wind or current who helped him this time around.
What software is used?
We're using SailSim 5, which is a virtual sailing software developed by Dutch company Stantec. It allows for a user to sail with preset conditions on a number of different vessels. Normally the input is given through a keyboard or a mouse, a joystick or a gamepad, but our goal is to have a person in a real sailboat controlling the game.
Why laser boats?
Laser boats can be considered as the most pure form of sailing. They involve only the basic controls, which essentially, fortunately for us, removes all the unnecessary complexity during the development of the simulator. Additionally, they're an important Olympic pass.
Why the main sheet?
A sailor has 4 contact points with a boat. The rudder, the hull with the hiking strap, the main sheet, and obviously his eyes, what this situation he sees in front of him. The main sheet is the rope, which controls the main sail position, and this is the contact point the sailor is most aware of and is constantly adjusting. Therefore, it's become the main focus of our part of the project. The other project groups will add onto the other factors, the previously mentioned hull, roll, and pitch, as well as the rudder control.
What will our test setup look like?
Our test setup is going to be a main sheet and rudder, which give computer inputs. The computer in turn controls an electric motor that moves the main sheet. Most of the work we put into the project is digital, converting software outputs to control the motor and vice versa. As this needs to be solid and clear to make it understandable for future project groups, it takes most of our time.
What are we currently working on?
We already bridged the first obstacle by having the motor receive inputs from the SailSim 5 software. We are currently trying to get the simulator to communicate back to the computer. Once this is completed, it should be plain sailing.
What challenges have we encountered?
The first challenge we encountered was to make us totally familiar with sailing a laser. Therefore, we dived both into literature and into the deep end by sailing a boat ourselves. The writing of the software decoder for the sail simulator output also seemed like a great challenge. However, after we learned the ropes, we made good headway.
What's the big picture?
We have embarked on the development of a serious tool for Olympic sailors, which they can use to improve and evaluate their performance. All of this to provide a copper-bottom training device for winning medals at the Olympics in Rio.